Hello viewers, welcome to this course on practical machine learning using Google Colab. In this tutorial, I will be describing about another image descriptor which is known as fast key point detector. So this fast key point detector is used to identify corners in an image. So after identifying these corners, we can use this as a feature vector and we can apply any machine learning algorithm on it to do classification tasks. Now let us start with the understanding of fast key point detector. So fast key point detector is used to detect the corners in the images. So the name fast indicates the key point identification is going to be very fast. So it can be used in most of the real-time applications or in resource constrained devices. So when a key point is called as a corner, so if I take a pixel and I want to test whether that pixel is a corner or not. So in order to do that, what we do is we try to take a circular neighborhood around that particular pixel, and if there are at least n contiguous pixels along the circular parameter with radius r that are either brighter or darker than the center pixel by a threshold, then it is called as a key point detector. So for example, if I want to take one pixel, so I want to check whether this pixel, let us take this pixel as p. So I want to check whether this pixel p is a key point or corner point or not. So for that, what we do, I take some radius. Around that radius, I take a circular neighborhood. So in this circular neighborhood, there will be many pixels. So this is the neighborhood. So what we are going to do is we are going to compare this neighborhood pixels with the center pixel value adjusted by some threshold value. So this adjusted by threshold value in the sense this center pixel value plus some t, or I can take center pixel value minus t, where this t stands for the threshold value. So I am going to compare this neighborhood value with either p plus t or p minus t. So if my neighborhood, in my neighborhood, if I have at least n contiguous pixels which are brighter or darker than the center pixel, then that particular point, center pixel, is considered to be a corner key point. So we will try to understand this with an example. So for example, here if I take this image, let us take this small region. So if I try to bloom up this region, so it will look something like this. So here I want to check this particular p. So to check whether this particular p is a center pixel, is a corner pixel or not. So in order to do that, I am going to take a radius of 3. So this is 1, 2, 3. So third pixel. So this is the radius of 3. So around this radius of 3, we are going to take the neighborhood pixels. So we are going to have something like, we have numbered the neighborhood pixels and it is coming about to be 16. If I take a radius of r equal to 3, then the neighborhood pixels comes about to be 16 values. So these are neighborhood pixels. So in this neighborhood pixels, I want to fix n value. So n in the sense I want to have continuous n pixels to be either greater in value when compared to that of the center pixel adjusted by threshold, or it should be lower than that of the center pixel adjusted by the threshold. So that n can be fixed as n equal to 9 or n equal to 8. So if I have 9 contiguous pixels with brighter values or darker values, then that corresponding center pixel can be considered as a corner pixel. So like this, we are going to do an analysis of the neighborhood for each and every pixels in the image, and thereby we try to find the corner pixels in an image. So let us try to understand with little bit more with an example. So here I take an example. Again, this is my center pixel. So here it has a value of 32. Let us keep the threshold value as 16. So which means I can either take p plus t or I can take p minus t. So if I take p plus t, it will be p is 32, 32 plus 16, it will be 48. Or I can take 32 minus 16, which will be 16. So I can take either of this value. So let us take p plus t combination for this example. So that I am going to take 48 as my center pixel value adjusted with the threshold, and I want to compare this with the neighborhood pixels. So here we have 16 neighborhood pixels. When I look at it from 1 to 8, you can see these values are smaller than your 48. Whereas from pixel 9 to 16, those are large values. So here I have only 8, n value is only 8 here. Okay, only 8 contiguous pixels are lesser than the value which we have chosen. So but we have selected the n value to be 9. So I want more than 9 contiguous pixels. So this point cannot be considered as a key point. It cannot be considered as a key point or a corner point. So let us take another example. So in this example, you can see here again same value, 32 center pixel. So but the neighborhood values have been changed. So again let us take p plus t. So p plus t, again t I am going to take it as 16. So thereby I will get 48. So I want to see whether my neighborhood pixels has a value of greater than 48 or less than 48. So when we look at it, except this 1 and 2, all the other pixel values are greater than 48. So which means I have about 14 pixels. So out of 16 pixels in the neighborhood, 14 pixels has larger value when compared to my this p plus t value. So thereby this pixel should be considered as a key point or a corner point. So that is how the corner is identified. So this corner key point identification is fast because we are just doing some simple pixel test computation. So thereby it is very fast. So let us try to do an example here. So first, as usual, we try to import the necessary functions like print function, matplotlib function for plotting, numpy for matrix computation, and cv2 for computer vision image processing libraries. We try to import it. Then I am going to take an image called as chessboard.jpg, and this image is going to be loaded into this location. So from this location I am going to read that image, take a copy of that image, then I am going to convert that image to a grayscale image using this convert color function. So cv2.convert color function, I give that image and I try to convert it from BGR to grayscale. Then we try to see how this original image looks like. So when we look at it, you can see this is the image which we have taken, for which we are going to do the corner identification. So the programming for fast detector is very simple. So here the fast detector can be initialized using this function cv2.fastFeatureDetector_create function. So we initialize the fast corner detection function, then use that detect function and apply that grayscale image to find the key points or corner points. So detector.detect of gray will give the corner points. So let us try to see how many corner points are there in this image. So by executing this, you can find there are about 201 corner points in this image. Then we try to go one by one on the corner points. So I try to take one by one the corner points, then use some variable r where this 0.5 is multiplied with this kp size, because the pixel value is very small. So in order to have it to be little bit bigger, we try to multiply it by 0.5 so that the radius can be little bit bigger. So radius we try to find, then we try to find the coordinate of those key points using this np.intp function. We try to find the coordinate of that corner points. So that is given by this x comma y. So after defining the radius, After defining the coordinate point, we draw a circle in that particular coordinate point using cv2.circle. So we give the image xy coordinate, radius, specify some color, and what should be the diameter of that circle is given by 2. So after drawing those key points on the image, so we try to take first key point, draw a circle, second key point, draw a circle. So like that we try to do it for all the 201 key points. So after that we try to stack both the original image and the modified image with the key point. Okay, so the modified image with the key point and the original image, we are trying to show it as a horizontal stack. So here you see we have the original image, and this is the image where the key points have been identified. So you can see the corners have been identified. So if you closely look at it, there are few corners which are not identified by this algorithm. So for example, here this location, the key point or corner point is not identified. Here also it is not identified. Other than this, most of the corner points it has been identified. So very few corner points have not been identified. So even though this algorithm is very fast, it is not able to identify all the corner points. So in order to have an improvisation of corner detection, we go for another algorithm called as Harris corner detector. So that we will look at in the next lecture. So in this tutorial, I have described about a fast key point detector which can be used for finding the key points. Once the key points are identified, those key points values can be used as a feature vector, and then we can apply different machine learning algorithms on it to do the classification tasks. So thanks for watching. Please subscribe for more technical learning. You can find the code in the following GitHub repository. Thank you.